Good morning to all. I am Professor Subramaniam from Automobile Department in SNS College of Technology. In this session, we are going to see about the transmission system. In transmission system, we are going to see about the casting of a gearbox casing, not the gear or gearbox. We are going to see about the casting of the gearbox casing of a gearbox system. The casting of a gearbox casing is a detailed process that requires precision and expensive to ensure the final product meets the necessary strength, durability, and dimensional accuracy for automotive and industrial applications. Design and pattern making. The process begin in this process we see about the first design pattern making, and next the mold preparation, melting and pouring of the metal, cooling and solidification. Finally, we see about the mold removal and cleaning, and it goes for the heat treatment, machining and finishing. Just then check for the quality control, and to the end customer it goes for assembly and testing. First, we see about the more. First, we see about the design and pattern making. The process begins with the design of the gearbox casing, typically created using the computer design, that is CAD software. The design specifies all dimensions, tolerances, and features required. Based on the design, a pattern is made, usually from wood, plastic, or metal. The pattern is exact replica of the gearbox casing, slightly oversized to account for the shrinkage during the cooling of metal. Next, we see about the mold preparation. The pattern used to create the mold. Sand casting is commonly employed for gearbox casings. In sand casting, the pattern is placed in a molding box and packed with sand and the bonding agent. The pattern is then removed, leaving a cavity in the shape of a gearbox casing. Cores made from the sand or metal may be inserted to create the internal features and cavities within the casting. Next, the melting and pouring of metal. The selected metal mostly use aluminum and rarely use cast iron, is melted in a furnace. The choice of metal depends on the required properties of the gearbox casing, such as weight, strength, and corrosion resistance. Once the metal reaches the desired temperature, it is poured into the mold cavity. This step must be performed carefully to avoid defects such as entrapment or incomplete fitting of the mold. And cooling and solidification. After pouring, the molten metal is allowed to cool and solidify within the mold. Cooling rate must be controlled to ensure the development of desired microstructures in the metal, which affect the mechanical properties of the final casting. Rapid cooling can lead to defects like cracking, while slow cooling might result in poor mechanical properties. Mold removal and cleaning. Once the metal has solidified, the mold is broken apart to retrieve the casting. This is typically done by mechanical means such as a vibration or hydraulic process. The casting is then cleaned to remove any remaining sand, scale, or other residues. This can involve shot blasting, tumbling, or other surface cleaning techniques. Next comes the heat treatment of the casting. To improve the mechanical properties of the casing of the casing box, casing of the gearbox, the heat treatment process such as annealing, quenching, or tempering may be applied. Heat treatment helps to relieve the internal stresses, enhance the strength, and improve the ductility. Then we see about the machining and finishing. The casting is then machined to achieve the final dimension surface finish specified in the design. Machining operations may include drilling, milling, boring, and tapping. Next, see about the quality control. Throughout the casting process, the quality control measures the implemented to ensure the final product meets the specifications. This includes visual inspection, dimensional checks, and non-destructive testing methods such as ultrasonic testing, X-ray inspection, or the dye penetrate testing. Thanks for watching this video. We'll see you in the next session.